This is the solution video to Assignment 3 and C Programming Assembly Language 2023 course. So let's start off with the first question. The first question is related to this bit of C code, which involves mainly this macro, right? So what does this macro do? The statement replaces wherever the macro exists as a C macro by A. So the idea is that it does not replace this because over here macro is existing as a string, not as a C macro, right? So it will only replace this by the character A, and so the output will be, so this is just now A, right, because of this declaration. And so the output is macro is equal to A. The output of this printf will be macro equal to A. Then in the second statement we are asked, regarding precompilation and then compilation, which of the following statements are true? You can see that statement 2 is a global variable declaration. Well, that's not true because statement 2 is a macro. Next, compilation replaces macro by its value only where it appears as a C macro. No, this is precompilation. So that is the third option. And then of course none of the above is not true. So over here for the option for question 3, I have given what a compiler and linker does separately. A compiler compiles C code to object code, right? Whereas the linker combines object codes into a single machine executable, right? So you can see that option A is true. And so for statement 1, which is the studio.h declaration, the idea is that the compiler will not throw an error. Sorry, the idea is that the compiler itself will throw an error because you will not have a definition for what printf is. That printf definition is in studio.h. So the compiler itself will flag this error, right? So if that statement 1, that is the header, is removed, the compiler error is thrown. So since it doesn't move beyond compiler error, you will not get a linker error, right? Syntactical mistakes, and so of course C is not true anymore, and D is also not true because you do get an error. Now syntactical mistakes are for pre-compilation errors, right? They are not for compiler errors, and so option E is true or is false, and option F is true. Now, what errors occur when the following code is compiled and executed? Well, since I have not defined this function callee _1 anywhere, you will find that, but I have declared it. So the compiler will not throw up an error, but the linker will, right? So in question 5, I have given the entire function definition itself. So therefore there will be absolutely no error. And so the option D is true. For question 6, I have neither given a header nor have I given the function definition, and so you will get a compiler error itself. That is, I have not given a function declaration for callee _1, and I have not included it in some header file either. So the next few questions are for this C code that has been compiled to this that has been compiled to the following output, right? And so let's go over it one by one. So question 7. So with respect to the main function, what is the minimum value of n0? So let's look at, this is where n0 is in question 7. So you can see that this is just the statement that corresponds to the three local variables, right? So the n naught value will be 4 into 3. See, so they're all int variables, right? And each int is a 4 byte variable, and so that is 4 into 3, so 12. So the minimum value of n naught will be 12, right? So for question 8 is for statement 13 of the C program, which is uh, over here. Sorry, that's question 8, right? So question 8 is for statement 13 of the C program, right? So when that is executed, what will happen? The idea is that when that is executed, those three are pushed into the stack by these statements, right? Which three? Which is the numbers that are given to the surface area surfar function, right? And so you will get that three pushes are happening, that is n1, n2 and n3. So question 8 is asking what n1, n2 and n3 are. So the order of the variable push is like so. First 2 gets pushed, then 5 gets pushed, then 3 gets pushed. So it's 2, 5 and 3, which is what I've given here, right? Similarly, question 9 is also for statement 13, right? So question 9 is for, so question 8 and question 9 are both for this statement 13. You know that the statement 13 will go to this call statement, and call can be given as the following two instructions, or implemented as the following two instructions. First, you have to push the EIP. So when call underscore when this call is happening, EIP will be C307. EIP always points to the next address after the address of the next statement to whatever is currently being executed. So pushing EIP means ESP will now no. So if you push EIP, it will go on the stack, which means the stack pointer will point. So the value that is pointed by the top of stack. So this is the value pointed by the top of stack, right? So that will be C307, right? And EIP will then get ADDR underscore 1, right? So if you're doing call ADDR underscore 1, EIP will get that value. And what is EDDR and ADDR underscore 1? It will be the first statement in the function call. So that will be C500, right? So question 9, the answer is ADDR1 is C500 and ESP will point to C307. Next we have question 10. So question 10 is about what reg1 is and what reg1 and reg2 are, right? So let's read the question. It is required to restore the context of the callee when the call function returns back to the callee, right? So we are asked what reg1 and reg2 are. So let's just go here. The idea is that, so this is all about function context setting, right? So the context of the caller, that is the caller function, is already in EBP, right? That is taken care of in the caller itself. It's just that the new context is now in ESP, right? That is again taken care by these push statements and this sub statement, right? So the new context is in ESP. So the idea is that you have to save the old context, which is this statement, which means reg1 will be EBP. You have to save the old context, and now the context gets updated. So EBP will now get ESP, right? So reg1 is EBP and reg2 is ESP, right? So that is what this answer is. In question 11, what is the minimum value of N5, right? So question 11, right? So this is N5. So you can see that there are there are three local variables, SR, dummy, and short Z, right? So three local variables, two of them are int, one is short, right? So this is the calculation for N5. So N5 will come out to be 10, right? So this will come out to be 10. Next in question, so this is question 11. Next, with respect to question 12, what is the qualifier? So question 12 corresponds to the statement where some variable is given the value 0. So that is this statement, right? So this is for question 12. And you know that this is an int. So int means this will be so this qualifier will be a double word, right? So that is the answer for question 12. The qualifier is double word because int is 4 bytes, which is a D word. There is two words. So in question 13 is N6, N7 and N8. Now N6, N7 and N8 come over here, right? These are the three statements for N6, N7 and N8, and they obviously correspond to the variables that are in the function declaration, right? So they are all three int variables, which means you will now get 8, 12 and 16 for N6, N7 and N8 because you also got, right? Because so they're all going up in increments of 4 because you've now got you've now got the integer variables, so therefore they go up in increments of 4. So the answer here is 8, 12 and 16, right? And then in question 14, what is the value of val1, right? So this is for question 14, right? So SHL, that is the instruction here, corresponds to shift left. So shift left means it takes some binary string like that and shifts it by left. It shifts it left by the value val1. And so what does this do? It means it is multiplying the number. If it shifts it by 1, it means it multiplies by 2, right? If shifts it by 2, it multiplies by 2 square, and shifts it by 3 is 2 cube and all that. So this is 2 power multiplication, and where that comes in the original function is here, right? So this shift left corresponds to that multiplication of 2, and it will be val1 is equal to 1. So shift left by 1. And finally, val12, which is add ESP comma val12, this will be equal to 12. Right? Sorry, not val12, that is val2. Yeah. So the value will be 12. And finally, these are the last two questions for this assembly output. These you can just verify is that the _ cdec convention is used, and the caller is performing the necessary operations for stack cleanup. And so the reason for this val12, this val2 equal to 12 is it's just doing the stack cleanup, right? Now that you've returned back to the main function, you have to uh, clear the space that was originally used. So in this sub statement, you've now allocated some space, and that you are clearing out. So you had allocated 12, right? So now you are clearing that out in the back. So you are freeing up that space by moving the stack pointer down by 12 again, right? So the caller is, so this is actually happening in the main function, and so we say that the stack cleanup is happening by the caller. And you can pause the video at this point and see that these are the true statements in the function. Pause the video at this point and go back to look at the function. You will be able to see that these are the true statements. So now we have this function, right? And you have to use the C++ so and so compiler in Godbolt, and you will see that when you go ahead and compile it to assembly statements, statement 5 will compile to A, B, and C, and statement 10 will compile to these. Right? This is just straightforward from the Godbolt website. And of course, the statement 14 will compile to this, and we're just asking what val is. Val will be equal to 12. And with that, we complete the solution video for assignment 3.